Yes.
No.
Okay, so now it gets challenging, right? We need to add and subtract these rational expressions. So what was the general rule of thumb when we added and subtracted fractions?
Same denominator.
Same denominator, very good. Okay, so we need to account for that. So if you look at the last example, it says 3 over x plus 1, right? Plus x over x minus 2. And I want to add those. Okay, before I do anything else, I just want to say one thing, because a lot of students get this wrong on the quiz and the test. And last year it was very frustrating because a lot of students still got this wrong when they didn't listen to me. So make sure you listen, right? If I have anything in common, can I just slash away things? No, because I am adding. I am not multiplying. I am adding. So therefore, you cannot just go ahead and cancel things out. Make sense?
Yes.
Please keep that in mind, okay? I need to come up with a common denominator. Because both denominators are not the same. One says x plus 1, the other says x minus 2. So what can I do?
FOIL.
Yeah, you're on the right track. You could FOIL. So this is what grading means. Wouldn't a common denominator for both of these be x plus 1 times x minus 2 over, and then x plus 1 times x minus 2? Wouldn't that be a common denominator? I think so, because this common denominator shares what? Both of the denominators, right, that we saw here. Think back to the fraction example that we did, right? I had something like over 5, and then something over 8. How did you come up with the common denominator for 5 and 8? Oh, you multiply them together, right? So isn't that what we're doing here?
Yes.
But now what's the only difference, though?
Yeah.
I know it's scary, right? Yeah. What's the only difference? We just have a variable. See that? It's the same thing. Okay, so that's what we're doing. Any confusion on that?
Yes.
Yes. Okay. What's your confusion?
Oh, I don't get it.
Hmm?
Wait, so we could just like, so they get the same denominator through same thing on top.
Yeah, you have to multiply both by the same on the top and the bottom for the factor that is missing. So very good. Okay. So this is what we mean. Yes. It's going to stay there. Okay? Right, so this is what's going to happen, right? You're going to multiply both this by this. So now, if you look at the first expression, it already has x plus 1, What factor is it missing? X minus 2. Very good. So now I'm going to multiply both things by x minus 2. So that's going to become 3 times x minus 2 over x plus 1 times x minus 2. Okay? Does everyone see what I just did?
Yes.
Only Brayden said so much.
Yes.
I don't know.
Yes.
No. Okay, so please listen very carefully. Right? This is my common denominator. If I look at both of these expressions, each of the expressions has one thing, but not the other. See that? X plus 1 has x plus 1 already, but it does not have x minus 2. So in order to make this expression match the common denominator we found, we need to multiply the whole thing by x minus 2, right? So that way we can get both of it. Okay? So think about the example that I put up, right? That I erased. If I have 1 over 5 and I got to change 5 to 40, I'm going to multiply the whole thing by what? 8 over 8, right? Is that the same thing like that? It's just with a variable. Okay? Alright, we need to keep going, so we're going to move on. Okay, so after the example, you guys will work on stuff. Okay, the last one. I have x over x minus 2. And I need to make the common denominator. So it already has x minus 2. It needs x plus 1. So it's going to be this. X times x plus 1 over x plus 1 plus times x minus 2. And then now, do they both have the common denominator?
Yes.
Yes. Okay. Now we can go ahead and add. Real quick, can I just eliminate things now?
Yes.
No!
Right? Okay, so for those of us who said yes and then quickly said, wait a sec, no, why not? Jay? No. Brandon, that's your first warning. It's because you're adding. Okay? So you cannot do that. Alright, let's go ahead and add them together. If I add it correctly, I'm going to get 3 times x minus 2 plus x times x plus 1 all over x plus 1 times x minus 2. Okay? So I just added them, right? I just did that plus and then x times x plus 1. Okay, but we need to convert this to standard form, right? It's the last step. Before we do that, what are my excluded values if I look at my denominator? Jules. -1 and +2. How did she do that? Zero product property. Thank you. So make sure you write that down. X is equal to -1 and then +2. If you use zero product property for the denominator. Okay, let's finish this up. So if I go ahead and FOIL this out, right? I need to redistribute all of these up top and I need to FOIL below. So 3 times x is 3x. It's going to be -6. Right, and then plus, I'm going to have x squared, and then x. And then in the denominator, you need to FOIL that. If you FOIL correctly, you're going to get x squared minus x minus 2. Okay, if you FOIL that correctly. And now we have this. The last step, you need to combine all the like terms, right, up top. Okay? If you do that, you're going to get x squared plus 4x minus 6, and then over x squared minus x minus 2. And that is the rational expression. So once again, what did I do? I redistributed all of this, I fell below, converted to standard form, but I wasn't done yet because I had to combine like terms. I do so up top, I get my rational expression. Okay? I want you guys to start on the worksheet and finish the rest of the problems in groups. Before we do that, I just want you to reflect on what we just did. Is this challenging?
Yes. No.
It's pretty challenging. Mona, can you share what you just said to me? Just share what you just said. Yes, can you say that to the class?
A lot of math.
It's a lot of math. That's why it's challenging. It's not that bad, right? If you make it so, right? So please, you need to make sure that you are being organized. It's a lot of math. Go step by step very carefully, okay? Okay, if you have a question, I'll talk to you one-on-one. When you have the rest of the class, to finish the worksheet, go for it. Time is yours. Okay, go, go, go. Yeah. Already has it. So think about this is what I'm saying, right? This is one of the first examples.
You know what I saw that
So we're going to multiply this by 4. What is 5? This is 8, right? So we're going to multiply 4 by 8. For this one, what is 8 plus 8? Okay, so now look at this. Nothing new, right? All we did was, I'm sorry, so we did not do that. All we did was we just added x. So now when I look at this, this says x plus 1, but what is it missing? X minus 2. So you have to multiply 3 by x minus 1. That's right. X minus 2, this is how we got this. See that? And what on this one? Missing. Yes, that's right. Does that make sense? So I think what's confusing is that I wrote this whole thing out. I'm writing out the common denominator so you can see what the common denominator is. So don't be confused about it. I just wrote this out so you know what the common denominator is. But each thing means it's all right to me. So that? Start from the other page and start working from there. You can't because we're adding. You can't just slash on next square because we're adding. Okay, go back to the other page. Let's work it out.
Wait, is this right?
Relax. Look. You can't just do that. None of it. We're subtracting, right? Remember when we said you cannot eliminate something you're subtracting, right? So how can we think this line? Because we're multiplying. It doesn't say 20 times x. It doesn't say 16 times x. It says minus 2. So you can't do that. So you erase this every time. Look at both of these and think about what you can take out. Okay? Yeah. Yeah, so look at first minus 12. Is there any number or variable or something that you can factor out or take out? Look at the top. Oh, very good. So take it out. So you 4 times 1. 4 times what's left. So it's like 4 times 1. Very good. You left them on.
I know who you guys like.
You are subtracting. Yeah. Hey, talk to your partner. I'll be there in a sec. Hold on. Okay, already I'm seeing a mistake that a lot of you guys are making, so let's come back together. Okay, let's come back together. Okay, still waiting. Raphael, take a seat, please. Okay, so on the first problem on the first page, you should see 2x minus 6 over x minus 3, right? Once again, you should see 2x minus 6 over x minus 3. Remember what I told you, if you're adding or subtracting, you cannot eliminate stuff. But I see a lot of students doing this. Oh, I see an x at the top, x at the bottom. Let me get rid of those. Can you do that? No, right? You are subtracting. You cannot do that. Okay, so you need to go back and think about what could I do to both these to take something out or factor something out. Okay? Okay, keep working. Go. Let's read. Very good. Okay, 1 for 1. Okay, now can you eliminate something? Why? Yeah, I didn't top. Well, you both like 2 by that, so now you know. Okay, so what's the answer? Yes, you got it. Good job. Okay, on the right track. Can you factor this any further? Yes, you can. So let's see what we can do. X what? Okay, but 12 doesn't have 2x. So factor out 2, which is great. But now look at x squared minus x plus 6. It's quadratic. Times what? Close, you're getting what 2 common factors within x squared minus x minus 6 can you create? Okay, 2x's, then what about the other side? So write your parentheses, right? Write your parentheses. Because you're factoring this out. Correct? Okay, so you said x, so you're correct. So it's x is going to be the first term, what's the second term? What 2 numbers give me 6? It's also going to give me. Very good. You got it. Look at first minus 3 plus 2. So it's going to be x minus 3, x plus 2. Okay, now you fully factored out the whole thing. Is there anything that you can't see? These are the 2 states there, right? 2 doesn't disappear. So now, yeah, so look at this, look at the top. Very good. What else? 2 on the 4, see that? Okay, so now what would be at what? So you convert this, right? See how there's 1 x minus at the top and there's 1 x minus at the bottom? Can't you get rid of those 2? The whole factor, no, the whole factor. Because it's 4 times that, it's 2 times that. Very good. Does that make sense? Or are you still? You know, I think it's going to help reorganize yourself and write out what you have left. Because right now you're rewrite the whole thing. That is the right answer. You got it. You got it. No, because I'm adding. I'm adding. Right? You can't do it. Okay, now let's go see yours. Right, let's go. Huh? It's not the remainder, right? But like, look at yes, yeah. Wait, so you got it. Okay, I think you know, I'll come and check it. I think you got it. Okay. You got it. So you need to find out what, like, use your product property, right? What value is going to give you 0 at the denominator? You need to figure that out. Okay? Alright, so now rewrite what you have. Because I think if you reorganize something, you're going to be able to get it. Okay, so what's left? Yeah, x minus. Yeah. Over what? And then what?
X squared minus x.
Okay, and then what did we factor that out to? Yes, very good. Okay, and then now see, this is what's confusing you. You put the same denominator twice. So why didn't you rewrite this and just put the new denominator that you just simplified? Does that make sense? Because you got like 2 denominators down here, and you're like, confusing yourself with the.
Wait, so this becomes this one?
Very good. Okay, so now is there anything you can eliminate now? Very good. Okay, is there anything else?
Oh, wait.
Up. So I don't see an x plus 2, but look at my numbers though. Very good. Yep.
So is this 2
Divided by what?
x plus 2?
Jacob, is she right? 2 over x plus 2. Very good. You got the right answer. So, remember what I said, right? You say it's confusing, I understand, but if you can't tell me why it's confusing, then I can't help you.
Confusing because it's a lot of numbers.
Yes, so that's what I'm telling you. I think what's confusing is that you need to stay organized. When you write, you step out, and then you get the right answer. But because you're writing numbers all over the place, I think that's why you're getting confused. So you try this next one. So try to stay like really nice and like one step at a time. Okay, so if you need another sheet of paper, I would do that as well. Okay? What number is going to give me?
I don't think he did that.
Yeah, I'm just walking around, yes.
No, but then they were like inside.
If you to factor, it's going to be 2 and
It is this, because if you factor it, it's going to be this. But then that doesn't add up to this. You know what I mean? Like, they can't factor it out. Like, you can't cross it off. Yeah, but we can do these. Could that make it then? Okay, let's just write that down.
Yeah, it's okay. This is the right answer.
Wait, I gotta look nice. No, don't you factor these out though? And then like you're just left with like 2x squared minus 2 over.
How many did you get the 12?
Right?
You're subtracting 12. You can't just slash 12 away.
Oh, he's telling you what I'm saying?
Go back and try it again.
I don't know, like
You guys what you're doing, but you're doing the mistake I told you. You can't just.
Then you gotta have such a weird right. Don't make it look weird.
How are you doing here, guys?
I don't know.
That is the right answer. Yeah, that's the right answer. You guys got it. Good job. Because you got a common denominator, right? You said you got it, right? And then now you just go back and you're on the right track.
If you're multiplying it,
Okay, remember what I said, right?
if you're multiplying it,
So aren't you subtracting?
3x times
You're not multiplying it, so you can't just get rid of it.
minus 5x squared.
You can't
You gotta make it.
You guys get it?
You don't really need to come here.
You're close. Look at 2x plus 4. Is there anything that you can simplify from that expression? Yes. Okay. So what do you have? Okay, but Brandon, remember what I said, you can't just eliminate 4. You guys like to do that, right? You're adding 4. You can't do that. You have 2x plus 4, right? So you can't get rid of the 4s because you're adding 4. You're not multiplying. Okay, but if you take out 2 from 2x and you take out 2 out of 4, what's left? And that is the right answer. That is the right answer. Got it. Okay. So, can you tell Brandon what you did?
Oh yeah. So you take out the 2.
Whoa.
No. Because if you take out the 2, then if you take out the 2, then you take out the 2 from 4, how much?
2.
Okay, so 2 over
X.
Plus, no, you have to take out 2.
So it's 2 over x. Thank you, and that is okay. So look, remember what I said. See how, like, look at this example. See how it's 4x minus 12 and 2x minus 12? Because you are subtracting, you can't eliminate it. If this said times 12, can you eliminate 12? Go right ahead, right? But you can't. So for this one, you were eliminating 4, but then I have plus 4. So can you do that? No. But if you look at 2x plus 4 down here, can you take out 2 from both numbers? And that's what Tatum was saying, right? If you did that, then you got that right there. Okay, now move on to this one. Keep going. Okay, we got about 20 minutes left. Keep working. Yeah, I know these are challenging, but you gotta keep trying. Okay, keep working. No.
You were showing us when we were sleeping. When you were sleeping. Right there. Yeah. The last one. Right there. You multiply the both. Because right here. Flip the page. You saw it. Right there. It's right there. Do yourself better.
X minus 3 times what?
Can we wait?
Yes.
Can I ask you guys a question? How would you guys say, because Mr. Hamilton said at the beginning of the period that this was a really challenging concept, how would you say it compares to the stuff that you've been doing so far in class in terms of difficulty?
There's a lot more math.
Is it harder?
No.
It's not hard. You got it on lock.
Yeah. No, some of it is hard. That's yeah. Just some.
So something I'm noticing that I don't always see in other classes is that it's hard, but you guys are working through it. Why do you think that kids work so hard in this class?
Because we're awesome. No. I don't know.
Is there anything in particular about this class that makes you want to work hard?
Yeah.
Like what?
It's the only class I can get an A in.
Why?
Because I work hard in it.
But why do you work hard?
Because I want to keep my A.
Okay.
Yeah.
It's like a chicken or the egg situation. Cool. I hear a lot about the fish philosophy stuff. What do you guys think of that? What is that about?
Do you guys want to share?
No one's really going to see this. It's just Mr. Hamilton is going to look over it later, so it's not like going to be published
so I can do,
online.
like, funny stuff on it?
No.
Oh,
He's still going to see it.
no. He's gonna. Tim, why are you just sitting here? Say something.
Fish philosophy. What is it? Go.
Well, fish philosophy is like a like a system where if you were to follow all of them, then you would technically you'd be like a very good person because you'd be helping other people and helping yourself at the same time.
Okay. What's the one that's hardest for you to do all the time?
To choose your attitude, because when you're really stuck on something, then you don't really want to be happy all the time. But then
Yeah. Would you say you're choosing your attitude right now by working through these hard problems? Yeah. Good. All right. Thanks, guys.
Bye.
You can say bye.
Bye.
You're minusing 12. You're minusing 12. We're not multiplying. So why is why?
negative
Go back. That's the right answer. That's the right answer.
Oh my god!
Yeah.
I don't know what to do.
That's the right answer. We're going to go on. Okay, some groups are starting to get this, so keep trying. You got to keep going. Practice, right? The extra practice will help. That's the right answer. Very good. Right? That's all you go. So start boxing. Do it. Next problem. That is the right answer. You got it. Tell me about that sort of guys. All right. Very good, Brandon. Got it.
Oh, and then negative 2 on the side like this. What did you get your 2? This is exactly the same thing as this, right? It's exactly the same thing. So you just put it on the outside. So I'm just like simplifying it right now. Do you get what I mean?
No, because you just told me to change this to next thing and then you moved on.
No, because if you just take out 2 and then you change, you can factor this out. Just this part. You don't change this at all. I didn't change it. So yeah, because look. Look, negative 3 times, negative 3 times positive 2 equals negative 6, right? And then negative 3 plus positive 2 equals negative x.
So like backwards for a fact.
Yeah, and then if you just multiply all of this, like, do the FOIL technique, it'll just equal to this, and then you'll just leave 2 on the outside. I mean, that's what I'm getting, because I don't know what's going on. And then for this, put this on top here.